2-day unit, and we did all of day 1 and day 2 in one day, and it was a lot for one day. By doing it this way, we're going to just look at the properties first, and then we are going to look at the the properties first, and then we will look at how to graph it day 2. So on day 2, we can focus all on graphing. Today we're focusing all on the properties. You have to be able to do day 1 in order to do day 2. Otherwise, day 2 is tricky. So let's see how we do. A rational function is a fraction. Oh, hold on. I should have filled out my notes before and I didn't. So if I pause, it's because I don't know what to put here. It's a fraction of polynomial functions. So it's exactly like what we did last unit. You have a polynomial on top, you have a polynomial on bottom. Okay, so same thing. If a function has a polynomial in its denominator, its graph has a break. I don't know what the right word is for that one. It has something going on at each of the zeros in the denominator. Because we know that you can't divide by 0, right? So if there's a 0 in the denominator, something weird is going to happen. Now, the gap could be a 1-point hole. And I'll show you what I mean by that. And when that would happen. Or it could be a location of a vertical asymptote. We haven't seen what that is yet, I don't think. You guys know what an asymptote is from secondary 1? It's been a while if you have learned it. An asymptote is a line that the graph can't cross. So sometimes you have vertical asymptotes and sometimes you have horizontal ones, and I'll show you the difference in just a second. So looking at these 3 different kinds of rational expressions, or rational functions, look at the denominator. Is there anything on this first example that could make the denominator 0? That will always be positive, right? So no value of x will make the denominator 0, which means it's a continuous graph. There's no breaks, no jumps, no holes. It goes on forever. Nothing kind of weird happens. It doesn't look pretty. It doesn't look like anything you've seen before, but there's no hole. Looking at this next one, what's the excluded value? X cannot be what? -2. Now, if you didn't have this y equals and you were simplifying it from last unit, you would cross these out, right? That means we're going to take that little piece of the factor away. Do you agree? We took it away, it canceled out. That's a way that you can remember that this is a removable discontinuity. That's how you say it. I'm removing this. I'm removing that from my function, and I would graph everything that's left. So because you can remove x plus 2 from the top and the bottom, at the point x plus 2, there's going to be a hole. And this hole right there. And the thing that you need to remember is that it's removable. How can we remember that that's removable? Because it cancels. Math is interesting. I'm throwing a bunch of definitions at you right now, and I'm hoping that you're catching on a little bit, but really the understanding is going to start coming once we start seeing examples, right? So if it's like, don't know what that means, just stick with me for a minute. Now, the last example, where's the excluded value? X cannot be what? 2. Now, nothing cancels here, right? Because nothing cancels, we're going to call this a non-removable. Nothing cancels. And because nothing cancels, I have a vertical asymptote right here. There's a break in the graph. Notice on the graph how this part goes down. It gets closer and closer to that asymptote without actually crossing it. And then it kind of jumps up and it goes this way. But at this point, x equals 2, or this line, x equals 2, the graph can't ever cross that. Because if the graph crosses that, that means there's a point where the denominator is 0, and then that can't happen. The denominator won't ever be 0. Okay, so there's kind of just a preview of the 3 different things that could happen. Either the denominator won't ever be 0, which means there's never going to be any holes or breaks or breaks in the graph, or the denominator will cancel with the numerator and you'll just have a whole. Or it doesn't cancel and then you have this weird thing going on. Graph through all sorts of pretty stuff. Okay, so let's see. If a is a real number for which the denominator of a rational function is 0, then a is not in the domain of f of x. So for this really quick, we're looking at what the domain and the range is. When looking for discontinuities, it's helpful to factor the numerator and denominator. So we're going to be doing this as the first step, just like we did last unit. The factors in the denominator will reveal the points of discontinuity and what kind they are. So, the other thing that you need to learn or to know, to find the x-intercept. X-intercepts happen right here, right? What does y equal on any of those? 0. So if I want to find the x-intercept, set the y value equal to 0. I think that's supposed to say y value. If I want to find the x-intercept, I'm going to set y equal to 0. And if I want to find the y-intercept, what will I do? So if you can remember that, that's probably something you need to remember just as fast as you know like 2 times 7, right? 2 times 7 is pretty quick. If I want to find the y-intercept, x has to be 0 because that's where x is on the y line. Same thing here. The x-intercepts happen when y equals 0. To find the y-intercept, I hate fill in the blank. Evaluate. Evaluate the function at, what did he say? Okay. Does this make sense why you would plug in 0 for each of those two options? No. Evaluate. Yeah. Okay, so what we're going to do with this example, we're having to find a few things. We need to find the points of discontinuity. Let's add. And we have to state what kind, either it's going to be removable or non-removable. Okay. Are the points, oh, just kidding, that's already listed on the prompt. Just ignore that. It's right here. Keep reading, you're fine. So we have to do that. And we want to find the x and the y-intercept. So there's 3 different parts of this prompt. The first thing is discontinuity. If I want to find where the graph is not continuous, because most graphs just kind of go on forever, right? They're continuous. Sometimes there's a break. The break is going to happen based on the denominator. So the very first step would be factoring the denominator and factoring the numerator. In this case, the numerator is already factored. But what about the denominator? Why don't you hurry and factor it? Here's factoring again to get a... Are we okay with that? X minus 3, x minus 1? So going back from our last unit, if we wanted to state the excluded values, so this is our discontinuity. The very first, let's number these. So 1, this kind of goes together, and then step 2. Okay, so the discontinuity, the first thing we have to do, x cannot be what? 3. X cannot be 1. Now, would these be considered removable or non-removable? Do they cancel with anything? No, so they are non-removable. I feel like I did take so much room to write that. So that's step 1. List the excluded values. That's going to be where the domain does something weird. And then are they removable or non-removable? Now, just for the sake of memorizing, if they are non-removable, that means I'm going to have an asymptote. It's a really weird word. That's how you spell it. Asymptote. No, because the word would be on your. Okay, step 2. I want to list the x and the y-intercept. So the x-intercept first. The x-intercept is going to happen when what? When y is 0. So just watch this really quick. If this is 0, how do I solve an equation like that? If x is 0, pretend like it said 0 equals x plus 3 over 2. That's a much more simple equation to solve. If it said this, how would you solve that? Times it by 2, and when you multiplied it by 2, what would happen? It's still just 0, right? Is that okay? Still just 0? That means, it doesn't matter what's on here. If it was x plus 2 and I multiplied it by an x plus 2, wouldn't it still just be 0? So it doesn't really matter what the denominator is. When I multiply both sides by the denominator, I still get a 0 on the one side. Do you agree? So when I'm finding the x-intercept, I really only care about the numerator. I'm going to change colors. X plus 3 equals 0, which is a much more simple equation to solve, right? What does x equal? Now, an intercept is not an x equals 3 line. Like, that's a line. An intercept is a point. So how can I write this as a point? Negative 3, 0. Good. Because if you were to graph that, do you want to shut the door, Fabiana? I'm sorry, you're the official light doorman, and it's a really obnoxious job. Ask Faith. And Carla is now yes. They're passing over the torch. If you're looking at the graph, isn't that x equals negative 3, so it would be negative 3, 0? That's my next answer. My first answer. All right, one more. The last thing we need to do is number 2. The last thing we need to do is find the y-intercept. If I want to find the y-intercept, what does x have to be? 0. So for this one, we're going to go back to our equation. We're going to say y equals, and everywhere there's an x, we are going to be what? 0 plus 3. Now normally I won't write that. Normally I'll just put 3. But I don't want to skip that step for the first time you see it. So 0 plus 3 plus over 0 squared minus 4 times 0 plus 3. How do I simplify that? 3 over 3, right? Is that okay? Which is 1. Now again, a y-intercept is a point. I don't want to leave that as a 1. I want to leave that as a what? Wouldn't it be 0, 1? Because x is 0. We plugged in 0. So my y-intercept is 0, 1. So I've learned from my mistakes. Don't write so big at the beginning because then you can't fall in at the end. It's ugly. Okay, so for the first couple of questions, we probably won't do all 6 of these if they're just 6. I feel like if you do maybe 3 or 4, you'll start to get it. Is that accurate? You think yes or no? Okay. Part B. If I want to do the discontinuities, I need to look at what? What is 0? Top of 0 or the bottom? On the bottom. What values could you plug in the bottom to get a 0? I'm looking at part B. Will this ever be 0? Oh. I never can plug anything into the bottom to get a 0, right? What's that? I. You can plug in I. Yeah, no, we're not going to do that. Usually I like to say we're not going to do that yet. I mean, we're not going to do that ever. No. You're right though. An imaginary number technically, but no. So that means for step number 1, are there any points of discontinuity? No, none. That means if I were talking about the domain, which we didn't ask you to do, but if I were talking about the domain, I'm going to say it's all real numbers. That little fancy R, if you don't remember, have we used that before? All real numbers. There's no point in that graph where x can't happen. So all real numbers would work. Step 2. For step 2, I want to find the x-intercept. Well, what do? If I'm looking for the x-intercept, y has to be what? 0. Okay, good. I always hate when the bell rings and I'm like in the middle of some great math moment. So, y equals 0. Now, do we care about the numerator or the denominator, or both? Do I even have to write down the denominator here? Because what would happen is I would multiply both sides by x squared plus 1. This would cancel, and this would still be 0, right? So when you're looking for the x-intercept, we don't care about the denominator at all. Okay, cool. So if I want to solve for x, what does x equal? X equals 5? But we're going to, we're going to put that into a point. So, again, Brandon, say it again. 5, 0 is the point. And we care about these because, again, it's kind of a stepping stone to get us to tomorrow when we're going to be plugging this all in onto a graph ourselves. I'll bring chocolate. You may need it. Number 3. Okay, if I'm trying to find the y-intercept, what do I do? All the x's become 0. Good. So looking at this one, I've got 0 minus 5, which is negative 5. 0 plus 1 is 1. So, what? Yeah, good. 0, negative 5. Just gets me all excited. I love this class. I love this class. I wish I could have you. Do I tell you that every day? If not, we went and visited Lone Peak and Pleasant Grove yesterday, and every class I observed, it was clear that, I don't know, that there was just a safety and a respect in that classroom. I don't know if I feel that with all of my classes, all 6 of them, but I hope that you feel that way, that you can come here and you can ask questions if you don't get it, and that you feel safe in talking to me if there's anything going on. I don't know, it was just really cool to see these teachers with their students, and no student had a phone out. Like in every class I observed, I never saw one phone, which is a sign of respect to me, I think. I don't see any phones now, so I think that you guys are golden. That's Josh, but I think you guys are okay on that regards, but I don't know, now we're on a major tangent. As a teacher, like I came into teaching because I love math, and I hope it's obvious, still really love this stuff. But I found quickly that it's, no, Brandon, I'm having this, like, I love you moment. You have to hold on for a second. I know, I can give you your homework. I'm just not going to. I just found quickly that it's my relationship with you that makes my job worth coming back. The job's way too hard if I didn't have we're not friends, we're not going to go out to ice cream on Saturday, but, having a friendship with you, like, it wouldn't be worth it. My job's way too hard. Everything I have to do, everything I take home, I wrote this, and it's way too hard to do if I didn't have that friendship with you. So I'm glad that you're here, and I hope that you feel that. And back to math. So it's very awkward telling you how much I think that you're wonderful, and then you're like, oh, part C, let's keep going. So, is it for number 3? For C? Okay, well, first thing I want you to do is what? So I'm going back to step 1, points of discontinuity. What do you do? Thank you for humoring my mushy moment. And not rolling your eyes, I appreciate that. Part C, what do you do? First step. Excluded values, yes, and, well, technically, we can list the excluded values. We know, for number 1, that x cannot be, what? 4. But do I know if that is a whole or an asymptote? You don't know that unless you can factor the top. Because if it cancels, then what will it be? A whole. If it doesn't cancel, it will be an asymptote. Try saying that word, it's weird. Asymptote. That P doesn't, you can kind of hear it? Asymptote. Asymptote. Okay, what does it factor to? X minus 4, then what? X plus 1. So yes, we do have factoring going on. Hold on, buddy. Canceling happens, which means is it removable or non-removable? Removable. Which means there's going to be a hole. Sure. As long as you don't put a non in front of that. I know. I know. Number 2. If I want to, what's number 2? X-intercept. If I want to find the x-intercept, what do you do? Yeah, 0, and we only care about the what? The top. Why? Ooh. Now, when I write this top, how should I write it? This is the first time we've seen something like this. Everything so far has been linear, right? So that x has been easy. But I got a quadratic here. So should I write the quadratic, or should I write the factored version of the quadratic? Yeah, factored version. Dang it. Why? Because how do you solve a quadratic? What do you got to do? Factor it, right? And if I can already write it down as factored, either x equals what? Oh, hold on. Strike that. Pause. Back up. I'm sorry. When I look at this and I'm setting something equal to 0, I care about the canceled version, not the original problem. Okay? So I only have to set it equal to x plus 1. Ooh, I hate when I mess up. I caught it, though. I caught it before it was too late.
Are we doing x still?
Because at that point 4, if I were graphing, I don't really know what it looks like, but if I were graphing it at 4, there's a hole there, which means it's not gonna be an answer because there's a hole. All right, so in this case, x equals what? -1, but we're gonna write it as a point because it's an intercept. -1, 0. Yes, yes? Okay, recap. We go based on the simplified version, not the original problem. The domain comes from the original problem. The intercepts come from the simplified version because technically -4. Oh, I hate that. Technically -4, 0. If I were setting this both parts equal to 0, sure, that's an intercept, except for, is that -4 or +4? Should be +4, right? Except for, what do we know right here? It can't be 4, so this can't be an intercept. Does that make sense? Okay, keep going. Y-intercept, you set what? All of my x's equal to 0. So, in this case, anything that has an x is basically gone, right? So what would it be? -4 over -4, which would be what? +1. How do I write that as an intercept? 0, 1. Very good. All of these points are key points on your graph that you will be writing in as we start graphing them. Jessica. Yes, you can. In that case, it shouldn't matter unless there's an asymptote or a hole on the 0 line, and then you wouldn't have. Oh, that's a good point. There's not an example on here. Let me see if I can find one where there's no y-intercept. So give me a second. Why don't you try part B? Do number 1 first. We'll kind of go piece by piece. Number 1, you try it, and then we'll do it, and then we'll do number 2, and then we'll do it, and then you do number 3, and then we'll do it. So see how we do. First step is to factor the bottom, right? X minus 4, x plus 4. Hopefully that was fast for everyone. Which means x cannot be what? 4 or -4. Nothing cancels, which means are these removable or non-removable? Non-removable. So does that mean, is it a hole or an asymptote? I usually stop at the P if I'm abbreviating asymptote.
Can I see the first line?
Sure. Okay, try step 2. Find the, as long as I know what you mean, Brandon, I'm good. Yeah. Okay, number 2, find the x-intercept. This one's different, right? Because we don't care about the denominator, yes? Now, if I plug in 0 for y, what do we have? Is that ever true? That can't work, right? So that means there is no x-intercept. Cool, number 3, now find the y-intercept. Because can 0, we're setting this equal to 0, right? And we only care about the numerator. Can 0 ever equal 1? No, so there's no intercept. What's probably happening here, you have vertical asymptotes, like if we go back up here, oh, just kidding. If we go back to page 1, you have vertical asymptotes where you can't cross, but you can also have what's called a horizontal asymptote. So my guess on that question is that there's an asymptote at 0, so it just never crosses there. We'll get more into that in a minute. But. All right, try to find the y-asymptote, or the y-asymptote, whatever. Y-intercept. Okay, for the y-intercept, we set all of the what? Sorry, I get excited and jump ahead. You keep trying it. In order to find the y-axis, or the y-intercept, we do what? 1 over what? This is going to be a 0, negative 16. So if I write that as a point, it's going to be 0, comma. Cool, try part E, all on your own, the whole thing. See if we can get this done before lunch, and then I'll pass out your homework. So those of you that are really excited to get started, can. Did y'all get your math Excel done?
Yeah. I did it once yesterday.
Yesterday at midnight? Reopen it for 1 day? Which one? 2. 2. If I remember, I will reopen it today for Friday. You're welcome. That's never opportunity time to make you think that I'm your favorite teacher. I assigned that the first day of Unit 4. So, did you not know about it? Dang it. That could have happened as well. Do you have a math Excel paper? Let me. Oh. The one thing I didn't do is I didn't give those first 10 people an extra point.
You didn't give me my bonus?
I didn't give you your bonus point. You didn't even take the test. I haven't given you the bonus point yet. No. I think I took a picture of who those 10 people are though, and so I will make sure that happens. No, it wasn't. It was for this. It was for the next coming test. So.
Yeah.
All right. First thing you do is what? Thank you. What's this going to be? X. Ooh, is it x minus 6, x plus 1? Or is it minus 2, minus 3? How do you know? This is a tricky one. It doesn't seem like it should be. It's all about the positive negative. So yeah, this adds to the negative 5, but it doesn't multiply to 6. It has to be those two. I was really excited. I was hoping something would cancel. Yeah, it has to be minus 2, minus 3. Because in order to get that positive 6, these both have to be negative. 6 is tricky. For such a small number, oh, it's open. Come on in. For such a small number, 6 is tricky. Okay, which means, is there anything that's going to cancel? So the points of discontinuity are 2, 3, non-renewal. Okay, go over one. This is the end of part 1.